Thanks for coming to this wonderful, hopefully wonderful and enlightening panel discussion where we're going to be talking about human intelligence versus machine intelligence. It's a broad topic. My job as a moderator will be to try to guide the discussion in a way that we can go into some scientific concepts, which we obviously passionately share with each other, but also take them at a macro level and give you all a bit of a more realistic perspective as in the front end. Can we bring those tools to actually think like you and I can have emotion states as the brain states of what neuroscientists know better than me. My name is Terry. I am CEO and co-founder of several companies. Two of the companies we are sponsoring as well, the conference. DK Lab is where we do fundamental research, and I have the honor of also working with our colleague neuroscientist who I will introduce soon to do some fundamental research around neuroscience. There are a bunch of other companies and ventures and investments I do in Europe, in Middle East, and also US. We'll not get into that. Without much ado, I'm going to start introducing my colleagues here. Can I invite you, Drazen, to on the stage, please? A big round of applause. I think a lot of folks in this region know Drazen very well. I have gotten to know Drazen in the past year, 2 years. We have grown and have a fond relationship and friendship, but mostly it is based on entrepreneurship. Many people don't know Drazen also has a doctorate in computer science and is a capable entrepreneur, but also a scientist at heart. Welcome, Drazen.
Thank you.
My next panelist is Jordi. Jordi, please welcome on stage. Jordi is a senior researcher at ICREA, also a scientist, a computer scientist, and a philosopher. So I'm very interested to hear also Jordi's perspective. And finally, obviously, our colleague Srikanth Ramaswamy, please come on stage. So Srikanth, I know Srikanth for a number of years. I think it's been 5 years or so, or longer. And Srikanth was a program manager of the Blue Brain project, which was led by the legendary, can I say legendary, Harry?
Yeah. Henry Markham.
Henry Markham, at least the way they pulled in a huge €1 billion project together with the United Kingdom had high hopes, and they definitely achieved a tremendous success. He's right now a professor at the University in Newcastle and doing the thing he loves most. He's a computational neuroscientist, and that is wonderful. I mean, so when you talk about computational neuroscience, I'll just start with a question already. How many people have heard of a name called David Marr? Not one.
Wow, well, I have, but I didn't raise my hand.
So David Marr, I think, I'm not sure if I could say he wrote a beautiful book in 1984, was that in 1982? He died, unfortunately, very young, 35 years of age. He wrote a beautiful book called Vision. If you buy that book, it can only be ordered on print. But again, with that, I think computational neuroscience is that bridge where we are trying to understand human brain and that revolution, let's say the parallel revolution, starting all the way from Frank Rosenblatt to Hopfield, where Jeff Hinton, together with Hopfield, they picked up a physics Nobel Prize. Well, it was in brain physics, we could say, has been a sort of a huge bone of contention to not just the computer scientists, but also philosophers in terms of, are we emotionally, offloading our questions to these systems and platforms, or can we build these systems that can actually think and empathize, and then the bridge builders like Sri are supposed to answer that question. So let's go quickly to that question. So the bridge building, Sri, how do you see and so let's start with the impediments, because we can close the panel with talking about the where we can make this happen make it succeed. Where do you see are the impediments to where we see, and we use this terminology in the papers that we've written together, is neuronal network, as in a brain space, versus neural network.
Right. So let's go back to Mar for a bit. In the late 70s, early 80s, so David Marr, Tommy Poggio, and Christoph Hawk, along with Terry Sejnowski, veritably laid the foundations for computational neuroscience, for modern-day computational neuroscience. And Marr's 3 principles of computation are really the cornerstones for modern-day computational neuroscience. I mean, that was just to provide a bit of history about Marr and the visionary guy he was. So going back to bridge building, so computational neuroscience has come quite a long way in its 3 decades or so of inception. It's still a relatively nascent field in neuroscience. However, I think the scale at which computational neuroscience has grown from modeling perceptrons to really modeling at the whole brain scale is quite phenomenal. But you did put a bit of a semantics question there. So this bridge building, we're still kind of stuck at the neural level mostly. And although we do have a lot of access in terms of tools and technologies and simulation know-how and whatnot to go down to the neuronal level, we don't see this yet in models of neural networks, because they're still models of neural networks. And most of these models are quite abstract, in that we heard from many talks today that almost all of these models are devoid of cellular heterogeneity, right? So just to give you a very quick example and try to wow you with numbers, even a tiny fragment of the rat brain that's the size of a pinhead, or about 0.3 millimeter cube in volume, has about 31,000 neurons. And these 31,000 neurons can be bucketed into 55 different types. So 55 distinct types of neurons based on their morphologies alone, based on the way their dendrites look, based on the way their axons look. And even to this day, we don't really have a way to model the cellular diversity in neural network models. So all neural network models pretty much have exactly the same kind of repetitive, identically repetitive units. So although, yes, they do display various forms of learning, they're still not a very powerful tool that distill the brain's amazing complexity and diversity into an approximate framework. So in that sense, I think this bridge building is happening, but it needs to accelerate at a much faster scale, in my opinion.
Thanks, Sri. Okay, so you're in the middle of the bridge, so you're trying to build the bridge. You talked about communities. And then on one side of the bridge, we have computer scientists, entrepreneurs who are using these platforms to serve their customers and providing some form of automation. I would say intelligence, using the word of intelligence already is a bridge too far. So what are your perceptions around intelligence, Drazen? What do you think that has AI proven its worth in terms of being somewhat intelligent to enterprises and your customers?
Well, it's definitely useful, but it's still, very limited to specific use cases. So still, it's very far from what we consider human intelligence. So not only intelligence, but all the other stuff that we as humans have, and actually computers and machines they don't have. And basically artificial intelligence and applications and tools, they are like super fancy, super cool. They can help with the business, they can help people in private life, but still they're very, very far. And actually there is one very, very basic difference, and that is the way of learning. Because we, as humans, we learn from experience. We also learn from books, we learn from other people, we learn from conversation, we learn by critical thinking, we learn by analytics and deduction. And actually artificial intelligence is learning from large amount of data. So that's the only source of intelligence and knowledge that artificial intelligence have. And basically we as humans, we have like many, many more different sources through our senses, through our ears, through our fingertips, through our eyes, nose. So we smell, we see, we hear. And this is something that's very, very hard to replicate if you are actually a machine.
Wonderful. So we're still walking towards some form of elementary intelligence. And Jordi, maybe I'll give you an analogy. I was having a discussion with some of our colleagues. One of wonderful colleagues, she, or a good friend of ours, who I'm not sure if she is here in the room. She's a quantum physicist, and we were having this discussion about intelligence. And I was reading a novel a couple of days ago, and I saw this term used, which I would like to borrow from that book called Project Hail Mary. It's an interesting book. So it was speaking about minimum intelligence. And minimum intelligence in terms of, let's say, low watermark, high watermark. So AI community is projecting maximum intelligence, ASI and AGI. And we are at a point, I would say minimum is probably a little bit too demeaning to human beings. We came up and we stood, and we are still standing strong on the food chain. But I would say, let's call it optimal intelligence, is to be able to survive and be able to create our own kingdoms and cities and palaces and ecosystems, and the animal kingdom where we came from, our ancestors. So we've actually plateaued already. We don't need to go to maximum. If there is a little delta of increment in that intelligence, that is good enough for us to even reach Mars. So there's no need to hyper-inflate the expectations. So what do you think in terms of this new, let's say, analogy that I'm talking about is like base intelligence works well for us already. A little delta is enough. How is that? Do you think that is sufficient, or do we should strive to break the barriers, work very hard with the neuroscientists, computational neuroscientist community, burn lots and lots of computational power, try to convince entrepreneurs like Drazen and the business community like ours to get that to some form of optimum, an improved optimum intelligence. So again, to summarize, I think it became a long question. What do you think is needed actually? That neuroscientists want to, they hope that something can be achieved computationally. The business community wants something to be good enough so we can use it. But the AI community is selling AGI already. That it'll be today, it'll be tomorrow, as Sam Altman has been saying this. So where do you think we should be?
Well, if we think about humans as high cognitive systems, just remind you that last week Donald Trump won the US elections, so not so rational, not so intelligent. So this is the real thing. There are several layers of considering intelligence. I remember when I read first time a 1990 a paper of Rodney Brooks, an expert of the MIT, about robotics called Elephants Don't Play Chess, that made explode my mind. So what is intelligence? For which purposes? For which things? We are discussing a lot about AG, about the evolution of AI, because there is a hype, but at the same time there are plenty of things that are changing and very powerful systems. And the real thing is that why do we need something to do something? For example, not so many decades ago, a computer won Garry Kasparov playing chess. Not so many years ago, a computer won Lee Sedol playing to AlphaGo. Lee Sedol was won by AlphaGo. It was a program created by DeepMind. The incredible thing is that the first program was trained, combined by self-learning and human learning for months. The second version was, I was checking for the exact moment, for 3 days. And the last version, without training and in just 30 hours, was able to train itself and learn how to win all the previous versions. So is this intelligence or not? It will depend about how we define it and for which purposes. So humans are very, very intelligent doing multimodal things, multimodal integration, plenty of sensory motor processes, but at the same time, most of humans are very stupid. Are liars, and it's part of our way of doing. Because when we are talking about human cognition, we always have in mind Albert Einstein, Marie Curie, or people like that, but not my neighbor, or I don't know, myself. This is a real thing. Most of guys are just repetitive, doing very basic things, not being creative, not being innovative. So sometimes we're asking for things that humans are not providing. This is something that we need to remind. So the point is to define what do we want and which are the tools that we need to create for solving that. So in some cases, things from minimal cognition are enough and very useful and not consuming a lot of effort or resources. And in other cases, other kind of approaches are very useful. But for example, ChatGPT costs hundreds of millions of training. Each new version, it's exponentially much more expensive than the previous one. And do we need that? Can we maintain this scalability in the process of learning? It's easier to use humans for some specific task and not another ones. So I think that it's like a ratio between the assigned task and the things that we want to invest for achieving some kind of results. We don't need quantum computing for doing normal arithmetic processes. It's like I remember that for doing very basic astronomical calculations, we don't need Einsteinian physics. It's enough with Newtonian physics. So sometimes the degree of precision adds so much complexity that perhaps it's not good. This is something that, for example, the robotics community understood very quickly, that it's better to make something like approximate computing than absolute computing, because the first systems that tried to see, understand, and plan were so time-consuming and data-consuming and computing-consuming that they were not useful. Then, if you reduce the expectations, it's like humans. You don't try that your kid do something perfectly. Just pick something and live there and work, not hit with the walls and something like that.
Okay.
With intelligence is the same.
I was doing this also in my, you watched that, right? The other panel. So I was stopping. So let's do the next theme. So the next theme is, and I will now play the devil's advocate. You saw that, we had an internal discussion during when Demis Hassabis, he got his Nobel Prize with his colleagues from Google DeepMind and also the US colleagues. So 2 DeepMind guys, and this other guy was a professor from other university, I forgot the name. So the devil's advocate question is that, oh fine, computation neuroscientists are saying brain is too complex, you'll never be able to build a model. Entrepreneurs are saying, well, if it can solve some problems, that's fine enough. And philosophers are saying, well, hey, I mean, you know, don't forget that, you know, emotion states of humans being deceptive and those kind of things cannot be quantified, leave alone that you're going to try to parameterize those aspects which are hidden in subtleties, especially when it comes to text and voice and emotion states, which we express through auditory and other sort of forms. But the devil's advocate's premise is AlphaFold now, with all that celebrity success that it has achieved and attained, is now talking about millions of experiments, and they are saying we might find new protein structures. Material science in Georgia University, I have good relationship with people who are developing an MOF framework to do material science, to kind of use AI to come up with new material objects where they're infusing the existing knowledge and then, for the lack of good word, throwing it into the algorithm and linear algebra, and then probably, I don't know, in a couple of years someone else will win a Nobel Prize in chemistry, when actually real chemistry would have been achieved, like real physics as well. So apparently some things are working. And why is that?
Some things are working, yes. But on the other hand, as Drazen said, I think we're still light years behind what these artificial intelligence systems can do to even get closer to human biological intelligence. So in some sense, what AlphaFold is doing is some kind of a very, very, very large scale predictive pattern matching algorithm. And over the past decade or so, thanks to the Human Genome Project and billions of dollars that have been invested into investigating the so-called mysteries of life, we have a lot more understanding for how these molecules are organized or arranged. And so there are immensely powerful data sets out there. And yes, I mean, again, the utility of these models can only be enhanced by the kind of data they're fed in. And if there's more data, sure, they can do a lot more better. I'm not downplaying any of what AlphaFold can do. But on the other hand, it's really a very, very, very sophisticated, large-scale pattern matching algorithm. And it's been trained to do that specifically. But in case there is some kind of an out-of-the-ordinary distribution in the data that AlphaFold is fed, can it really go the extra mile and generalize and connect the dots like a biological neural network can do? I don't know. It needs to be tested. Sure, there's a lot of promise, but we're certainly not there yet. I think the coming years will tell us how close can we really get to achieve anything closer to biological or adaptive intelligence. So we're still at the tip of the iceberg. We're skimming the surface. It's good we're making this progress, but we're certainly not there yet.
Okay, now Drazen, let me just give you a small twist to that same question, but the twist is like that your startup with the legal
legit.
Yeah, legit. Let's say you had access to not gigantic, enormous amount of data that quantifies every little aspect of looking into each and every clause and figuring out things, being ultimate, super innovative in providing solutions in that realm, and massive, and you got $10 billion, and you got access to that data set, so you had that monopoly of capital as well as access to that data set. Don't you think that could be possible, like AlphaFold, to that domain?
It is
or
possible.
Is it too stupid a question to ask ourselves?
It is possible, but it's still a limited use case. So it's still not real human biological intelligence. So, I mean, it's amazing how human brain is complex. So, I have one question for the audience. So, do you know maybe how many watts human brain needs to operate? It's 20, so 20 watts, yeah. So, but 10, 20, 200, it's still very small amount of power and, of course, small amount of energy. And actually, our brain, I think, is using like 30% of our whole energy in the body. And it's amazing how much things we can do with our brains with only 20 watts. I mean, the normal, you know, light bulb is like 60 or 100 watts. And that's purely amazing. But one limitation that we have with our brains is that those are our brains. My brain is my brain, not Tari's brain. So Tari cannot use my brain, only me. Only I can use my own brain. And if you were watching like Star Trek and Borg and Collective Minds, so that's something that is actually like, I mean, for the scientists, for neuroscientists, should be like holy grail, because when we pass away, everything that's in our brains pass away with us. So mirroring this brain, our brains, knowledge from our brains, somewhere in the cloud, and you are nodding a lot, would be, and making this experience and knowledge and intelligence reusable would be like holy grail. And why ChatGPT and those AI things are so useful? Because they have prompts. So it's like one intelligence, but tens or hundreds of million people can use it. So that's the big difference, essentially.
Thanks, Drazen. So now, Jordi, finally to you. I was looking at a clock. It says 3 minutes. Is it? No, it isn't? Okay. So, yeah, okay. Because I had a last kind of a round I wanted to do. So, Jordi, so, you know, I get a feeling that Sri and Drazen are kind of invalidating the huge success. I'm pulling your leg, but obviously for a certain reason. So a lot of data in a certain specific domain somehow achieves some success, which is mass scale hyperparameter search in this huge data pattern selection identification, and that has achieved success, while in a certain domain it's human ingenuity to craft a certain legal framework which is based on a new situation that doesn't exist in the repository of the data sets, and therefore 20 watts of that person's capacity is 10 times more its weight in gold. So we are seeing that some kind of dichotomy in one domain makes sense somehow. In the other domain, it's better to use human ingenuity. Where do you think is the real trade-off?
Well, yes, thanks. I want just to add something in relation to, because when we are talking about brain, yes, it's 20 watts, but no one single human can do all the humanity products. So we are millions of guys producing a lot of things for centuries, millions, thousands of years, thousands of engineers describing small things, very difficult things. So at the end, it's the sum of a lot of energy, a lot of efforts, of all collective ways of doing things. So I think it's a, I understand, because we are using even for some kind of publications this kind of comparisons, but the generation of knowledge is a collective project. It's not just one mind that makes something, but it's not only because we are talking about like brains, walking brains, and it's not just walking brains, it's social brains doing things. For example, in this, today we have been talking a lot about neurotransmitters and things like that, but for example, oxytocin has not been quoted. Oxytocin, it's fundamental. It's the hormone of love, the hormone of sex, the hormone of the bond between mothers and newborns. And it's fundamental. Without oxytocin, there is not social existence, no cooperation, yeah, no empathy. This is not based on just computing. It's based on some kind of architecture of the brain supported by hormones. So once they say that, I think that it's a mixture of processes. It's not just theory for here and industry on the other side, but it's like the necessity of joint ventures trying to generate new tools for solving problems. I think that, again, the point is to find solving problems.
Awesome. I think this is very good. Actually, what you say is you're right, oxytocin, but also, there's lots of research around gut microbe and how that interconnects with our brain. So there are several areas, which is like, here's your gut, and in ancient wisdom is gut instincts. Now we're talking about gut microbe that kind of can influence the neuroscience. Cortical circuitaries in your brain in certain fashion that allows you to make a decision, apparently. Talking about that, then let's go into that, decision states where we know that dopamine plays a significant role, and not as much, perhaps, depending on the target sections. And I'm just repeating the poster that we wrote together. But more specifically, I remember there was a paper Jeff Hinton had written after backpropagation. How many people are familiar with those kind of architectural models like backpropagation? Okay, so there's good understanding there. So there was a paper in 1970. It didn't get much publicity. Occasionally he writes papers just on his own as a sole author. It was about circular propagation, in which he was trying to at least hypothesize on that there are different ways of I want to extract and improve the feedback loop instead of this whole network pass. And then we have seen authors like Tim Lillicrap and Blake Richards and the likes who have been actually advised by Jeff Hinton, apparently wanting to try to revive the new sort of update mechanisms. So what I'm trying to get at is people are trying hard in the computational neuroscience field to like credit assignment systems, etc. So there is some hope in that bridge, no? So there is some hope that we will be able to quantify and perhaps bring the neuronal and the neural architectures to somewhat, coherence, that we can achieve, if not as much as emotional states of, how the hug in certain amount of releases oxytocin, and especially even in spouses, they say that, and I'm learning that as well, hugging my wife and it calms or soothes her, apparently soothes me as well, so these are very important things which perhaps will maybe in several decades we may solve, but now there are some mathematical models where folks are trying to derive, all the, things like what happens in a striatum and an amygdala and hippocampus, basal ganglia, etc., those kind of areas. So people are trying that. So there is hope, right?
Well, yes, there is hope. But on the other hand, concepts like backprop or gradient descent, these are yet to be conclusively demonstrated in the brain. And there is no one-size-fits-all. So Max had this question right after my talk this morning that why are we so focused on the cortex? Because there's a treasure trove of understanding that's to be had by looking deep below the cortex. So the thing is, there is no one-size-fits-all, right? Just because the cortex functions one way and solves a particular task by implementing whatever algorithm I don't think one could say that the striatum or the amygdala or the hypothalamus would also do things in the same way. So one, there is a checklist of components, neurons, their synaptic connections, the microcircuits they form, importantly, the long-range inputs they receive, and neuromodulatory drive. So all this comes together as a package at any given point in time to dictate the kind of computation. And this varies drastically from brain region to brain region, right? So there are streams of distributed information, and sometimes to process a certain task, like several different brain regions come together, and there are these long-range projections that bind these areas together as a thread, and then soon after that's done, there's this task switching. You need to go to the next task to do this, and all this is happening in parallel, just as I speak. I have a lot of these thoughts coming into my mind, and it's not that they're all being done with the same kind of algorithm, with the same approach. It's different. So I think we need to think of ways to move away from having this snapshot view of the brain and trying to think of what could be going on over a longer and a longer time scale, like continual learning, and how the brain does this, and how the brain recalls what it's learned and replays it. All this is very important, and though some of these algorithms have bits and pieces of this, I don't think we have a cohesive algorithm that brings all this together. And that's difficult because not all brain regions are working exactly the same way. So the bridge is narrowing, but there's still a lot of territory to cover.
Okay, the realistic and pragmatic answer. So Drazen, basically, so let me kind of reframe the question. So actually, and perhaps it's also kind of my response to you, is we don't need to find a bridge and have that convergence happen in its totality. We are super comfortable in having those parallel highways. And that reminds me of, again, I think it was Jürgen Schmidhuber's paper on highway networks, and then SNNs and those kind of things. We had that lecture or workshop day before yesterday. I really enjoyed that, by the way. And so we can have, these highways where if you can reduce the distance between these parallel tracks while understanding the dynamic nature of how, for example, a certain secretion of these 4 chemicals where oxytocin is not included, sorry, but for now I think those, and the distribution of that lets you decide with that a priori, that memory, what action should I take, because the next time you use that same information, you're taking another action, stores back into hippocampus. So if the distance between these 2 highways is reduced without them desperately trying to converge, we're happy, right? All we need to do is bring more automation into various aspects of our lives, being able to let one employee do the task of 20, because even if you would want to be, very, very, charitable to your local community, you may not find people with that talent, because simply that in that area there are not enough students who are learning that art, so it helps my employee to get productive. Aren't we happy with that outcome if we are able to just reduce the distance between these 2 parallel tracks?
I think this is something that's already happening. So you already have systems that are functioning in that way. So one example that is very common are autonomous vehicles. So basically they are combining different types of AI models to see through LiDAR or whatever what's around, to make the decisions, to speed up, to be able to go to the destination, to be able to make the decision in critical situation. So that's actually a very, very good example of those narrowing highways. Also, very popular topic recently are multi-agent systems, and they are released for various businesses, various topics, where actually you have different AI agents that are doing different tasks for which they are specialized, and they are communicating and exchanging information among themselves to be able to solve complex problems. And I think we can be fine with that, because there is a lot of work and less and less available workforce. I think Earth will now go into this depopulation phase in maybe next few hundred years. Maybe we already reached this top number of people, 8 point some billions. Maybe it will grow to 9 or 10, but
then we'll see a population decline.
We will see the population decline, not for wars, not for I don't know, some, you know, catastrophic events, but just for the reason that a lot of people would stay single, a lot of people would have only one child, a lot of people will prefer to have the partner of the same sex. So there are different reasons, and we can see already in Europe that Europe is getting older. China also had this kind of thing. So all help that we can get from the machines can be very, very useful. But of course, we still need to be careful. I don't think that AI will, at any point of its development, try to destroy humanity, but there are things that can happen, like bugs and errors and wrong prompt engineering, and this stuff can happen. So we really need to be careful and have good triggers that could stop something bad happening. Just maybe one like example. So try to imagine to have like a AI model with the task to extinguish cancer in humans. And actually, what is a prerequisite for cancer? Prerequisite for cancer is a live human being. So how can you eliminate the cancer completely? To kill all humans, so no more cancer. And it's a solution of the problem, but it's not a good solution for the problem.
So I will take the last part of your comment with a bit of pinch of salt. But I think, so the reducing the distance is perfect. We are happy with it. You know, demographic perturbations that, you know, I'm sure human society has had through generations, and now we're going through the down cycle of, so I understand what you meant, so it was not misunderstood. It's not depopulation through rogue actors, but it's just pure natural causes of how our societies are evolving. But okay, let's, and I think to end that with a little bit of a spicy note, so we have these two parallel tracks, okay, Jordi? And this is our computational neuroscience, and this is our, you know, GPT version 7. So, and then we see that the computational neuroscience has plateaued for whatever reason, and I'm just going to draw it this way, and the computation with vast amounts of data has exceeded human intelligence. So where do we stand there if that happens? depending on how we measure that. It's not like the MBTI score of intellectual quotient or IQ or any other forms or ways of measuring that it's intelligent. Math scores, SAT, GMAT, GRE, but it exceeded, we all gave up. We said, okay, fine. What happens then if we do that? Should we celebrate?
Yes.
Or should we worry?
Yeah, why not? To be able to find solutions to problems that we have been fighting for thousands of years. It's something that it's fantastic. Why not? The real problem is who will own this technology? Because again, AI knows it's nothing that it's like a ghost there outside. There are companies using data, stealing data, in fact, not paying the taxes that they must to pay. And then if this AG or whatever that appears, who will be in control? Not in control, who will have the ownership of this technology? So this is the real thing, because at this moment even, I think in Australia, like 2 years ago, was given the patent of an invention to an AI system, not to the creator of the AI, but to the AI. But because of the AI has not citizenship, cannot receive money, therefore the money goes for the creator of the AI. But the intellectual property is for the AI. So
that's interesting.
yeah, it's very interesting. It's something that it's new, but it's related to regulation with military geostrategic issues. So I think that it will not just happen, but it will happen in a specific places with a specific resources, with guys controlling this kind of research, nothing out of control, surely, because all of the doomsday scenarios is that AI will rise one day and kill off all of us. So it makes no sense. Up to now, I think that it cannot happen. There are plenty of controls. But in any case, we should ask ourselves who is in control at this moment of these technologies and why we allow these kind of things that are already happening.
Awesome. With that, I think we have kind of approached, we have, I guess, a few minutes, maybe 5 minutes. So, and obviously there's a lot of questions you have in your heads. I'm sure not every question you would want to stand up to ask. You can always ask us later, but I definitely at least want 3, you know, just to put a little bit of a pressure on all of you guys. And I just told one of the ladies sitting at the back just before the panel that I can walk up to you and make you ask the question, but I'm not going to do that. No, don't worry. I meant the other one who was sitting there. That's the one I was referring to. Okay. That's okay. Oh, you did hand her the mic. Okay, so you put her on the spot. Anyways, I mean, you're free to ask questions, please. Yes, there, Sava.
Super interesting discussion. So I really like what Jordi, you said about the different types of intelligences that are in the world. Like, you have billions of minds, and so different kinds of capabilities, and also that it feels like we're spending a lot of time modeling the human brain to try to figure out how to dissect this. And the first question is, are we getting too deep into weeds on trying to figure out what the human brain is doing versus figuring out what is just novel intelligence? That's question one, and I'm in the camp of I got a running bet that we'll get AGI in a year, so I'm in that camp, and we'll see in a year. But you know, why don't we look at kind of outcomes-based intelligence as a measure of what's there? And it's you know, we're trying to come up with these tests, but why not look at like a decision-making test or other tests? Because we're skewing how we track progress. I mean, it's inherently subjective. And so the first one is, are we going too deep on trying to figure out how the brain's working to figure out how far we've come? And second is, do we really need human intelligence, or is there another way of looking at this that's much more practical that can go on a completely different direction, similar to like AlphaGo doing move 37 or whatever it was, that introduced a completely different way of thinking about certain problems that humans up to today did not think about?
Awesome, thank you, Saba. So just to kind of make sure that all the three of you get an opportunity, can we just like keep it to max 3 sentences? Each sentence, no more than 9 words?
So, yes, we are probably going a little too deep, but research in neuroscience is going to happen independently of AI. So, for the artificial bit, you always need a natural or a biological counterpart, right, to kind of complement things. So we have made progress. I fully appreciate that. And at the end of the day, not all details of the brain matter. It all boils down to what kind of a model system you're going to build and what level of detail matters to constrain such a model system. So I think if you're able to work that out, then it's all right.
Drazen.
So I think we are modeling artificial intelligence to human brain because this is the highest level of intelligence that we know. But there may be other types of intelligence in universe that are completely different that we don't know. And I think what we need to do is to model artificial intelligence to do stuff that we need to help us and not to be as human as possible because it doesn't make sense.
Jordi?
In 2016, Microsoft created a chatbot using Twitter, and it was a chatbot that was able to learn using the
That's
all
the one,
data.
Tay or something, right?
Yeah. And in 24 hours, they had to close the system because you can check the tweets, incredible, ultra racist, ultra gendered, and a Nazi even, yeah, defending Hitler, things like that. So this is my response.
Basically, dataset was 4chan. Any other questions? I can't come. No, I'm not going to do this. Thank you so much, all of you. You know, these 3 gentlemen are around. Thank you very much.